Hey, welcome back. In this video, I'm going to show you how you can get started creating WebAssembly modules using the programming language Rust. Now, as I said in my other videos where we hand-coded a whole bunch of WebAssembly modules, you'll probably never hand-code WebAssembly for real-life production scenarios, and you're probably always going to use a higher-level language which would compile down into WebAssembly. Now, for this reason, we're going to look at the programming language Rust today, but of course there are other programming languages you can use, such as Go or C or C++ or AssemblyScript, and we'll probably do some other videos on that at some point. But Rust is one of those very popular languages and is actually really well designed for creating WebAssembly modules. And as I said, in this video, we're going to get started. We're going to create a couple of WebAssembly modules. We're going to see how that looks. We're going to see how that compares to hand-coded WebAssembly, and then we'll get that up and running in the back end in Node.js and probably in browser as well. So with that, let's get started. Okay, so before we get started, first thing you need to do is have Rust installed on your machine. If you've never programmed in Rust or you haven't got it installed, then actually I've done a video on that already, so just go check it out. It'll probably appear in the top right-hand corner of your screen there, and that will show you how you get started. But if you haven't used it before, to be honest, it's pretty simple, and it'll be fairly quick to understand even within this video. Okay, so on my machine, I've already got Rust installed, but actually I need to install something else to be able to create WebAssembly, and that is a thing called wasm-pack. Now, how I'm going to do that, so if you look at my terminal in front of me, is I just need to type in the word cargo, which is the package manager for Rust, very similar to npm, and then I type in install, and then I just type in wasm-pack. And then if I hit return there, then that's going to go and create that. Now, as you can see on my machine, I've already installed that, so it's going to be fairly quick to install. I could use the -- force, and that would show you what the installation for that would be like. In fact, why not? Let's do that already, and why not? So if I just do wasm-pack -- force, and then that's going to install that. So you'll see it'll take a little bit of time. It's going to download a whole bunch of stuff, and then it takes some time, and then that will be installed. Okay, so as you can see, that's now installed. So wasm-pack is on my machine. So let me just clear my window for a second. And if you're unsure if wasm-pack is installed, you can actually just type in wasm-pack -- version. And if that runs, it'll be successful by telling you what the version number of wasm-pack is. So you can see on my machine, it's version 0.10.1. So I have that installed on my machine. Okay, so cool. I've got wasm-pack installed. So the next thing I need to do is create myself a library. So because I'm essentially creating WebAssembly modules, I'm not creating a executable program. I want to create a library in this case. So how I would do that is I would just use cargo in the same way as I would use npm with something like JavaScript, and then I would say new. So I want to create a new package, a new library. I want it to be a library, so a lib. So it's -- lib. And then I just put in the name of the package that I want to create. So in this case, I want to call it chris-math. And then if I hit return there, then it will automatically scaffold up some packages for me. So if I just do an ls here, you can see it's created that chris-math, and then I'll just cd into that. We'll clear that out, and you can see it's got a cargo.toml, and we've got a source folder. What I'm going to do is I'll explain what's in the cargo.toml in a second, but the first thing I'm going to do now is I'm just going to open up vscode on my machine, and then we can have a look at some of the code that it's generated. To do that, I just type in code dot in the terminal, and then that will launch me vscode. So as you can kind of see there, I've got this cargo.toml file. Now, the cargo.toml file is very similar to a package.json in JavaScript or in Node. So we'll explore that in a second. You can see standard things like a get ignore, and again, a cargo.lock, again, very similar to a package.lock.json file in npm as well. So in the source folder, that is actually where you're going to create your library. That's where your Rust code is. And then this target folder here is actually where, when I build my package, that's where the code I'm building gets placed. So if I look at this, you can kind of see that it's automatically created some tests for some Rust code. So I'm going to delete that because I don't need that. and then we'll create some code from scratch. So in order to create some WebAssembly in Rust, I need to actually, first of all, open up my cargo.toml. As I said before, it's very similar to a package JSON file that you have with NPM. So you've got this sort of area here, which is the package area, and you've got Chris-Math as the name, version 0.1, and the editions 2018. And of course, you can add lots of other things and metadata within there to do that. Now, if you look at the video that I created, which is calling Rust code from node.js, I go into a little bit more details of some of these attributes. Now, what I need to do now is, because I want to create a WebAssembly module rather than a standard Rust library, I need to specify the type or the crate type for the package that I'm creating. So to do that, I need to just add in lib here, and then I just need to say what the crate type is going to be. So in this case, I want this to be a library that can be called from externally using C-style function declaration formats. So to do that, I need to set that to cdylib. And that's basically saying it's a dynamic library, and I'm exposing any functions that I create with a C-style syntax. So any C-type application can be able to call that. And again, in my video calling Rust from WebAssembly, I go into this in a little bit more detail. So that's what I kind of need to set that for. By default, I think it's rlib if you want to do Rust libraries and call from Rust programs. But again, we're going to be calling it from the outside world because we're going to be creating WebAssembly modules. So once I've set that, the next thing I need to do is specify any dependencies that I have. So I'll just create dependencies in my brackets here. And then the dependency I've got, so the package dependency I have is I have this wasm-pack package that I want to use. So I'm just going to set that in here, and I can put in the version numbers. So it's going to be 0.2.78, and then we're good to go there. And again, that's just the current version there. If you look here, it gives a little tick. And then it will show you what versions you've got installed locally there. But as I said, the version that I've got at the moment is 0.278. Okay, so now that we've got our cargo.toml done, what we're going to do now is create our code. So within our librs file, what we're going to do is create a function that's just going to add two numbers together. So to do that in Rust, then functions are declared as fn rather than functions. So it's just fn. And then I would give it the name that I want. So I'm going to call it add two numbers. And then I can accept in parameters. So in this case, I want to add two new 32-bit integers together. And I'm going to call those parameters n1 and n2. So if I just put n1 and then specify that as an i32, and then my second parameter is going to be called n2, and I'm going to specify that is a 32-bit integer again. And then I want to return a 32-bit integer. So the way you declare a return type in a function declaration is basically using a sort of an arrow. So that is the minus symbol and the greater than symbol. And then I just specify the type that I want to return it as. So in this case, a 32-bit integer, which is i32. And then I'll just create my brackets so that I can create the body of my function. Now, in this particular case, this function would be private. If I want to make this public to anything outside of the module, then I need to just specify it's public by saying pub in front of it. So there we've got my function called add two numbers. I just need to create my body. So I want to add two numbers together. So to do that in Rust, then I would just do n1 plus n2. Now, because Rust is an expression-oriented language, then I don't need to specify return. It will take the last statement as a return value. And I also don't need to semicolon terminate that. If, however, that bugs you for whatever reason, if you wanted to and you wanted it to be more of a statement, you can do return, and then you could semicolon terminate it there, and then that would work in the exact same way. But as I said, Rust is an expression-oriented language, so you don't need to necessarily return, and you could just do n1 plus n2. And again, that expression orientation is really useful when you want to start using more sort of functional constructs. Weirdly enough, with WebAssembly, this is actually kind of closer to when you're hand coding WebAssembly, because WebAssembly is a stack machine and you're popping things on and off the stack. Then in the same way as Rust takes the last statement, WebAssembly actually, whatever is on the accumulator is the last thing on the accumulator in your function, then that is what actually be returned from the function in WebAssembly. So it's just something to be aware of when you're handcoding. So in some regards, this is kind of closer to WebAssembly. And actually, when we look at the WebAssembly later on, the way the Rust code is actually incredibly similar to how WebAssembly is when you hand code it in WebAssembly text format. And we'll hand code something up in a second, but you can kind of see, you've got function declaration, 2 parameters, survive 32, return 932. It's quite a similar syntax in some regards. So so to be able to translate between WebAssembly format and Rust, it's not a massive jump. Okay, so we've done that, but one of the things we haven't done is specified that this function is something that we want to put into our WebAssembly module. So in order to do that, we have to specify a WebAssembly bind generation. So we do that with a decorator. So we would just say hash and then square brackets wasm_bindgen. And then that way, when we put that on a decorator function with wasm-bindgen, then we know that is a function that we want to be made available for in the WebAssembly module to be compiled. So that's really all we need to do. Of course, you've got these red squigglies at the moment because it doesn't know anything about that just now. So this is where we have to remember that dependency that we created in our toml, which was the wasm-bindgen. Well, yeah, it's the exact same thing over here. So now that we've sort of decorated that function, we're saying we want to generate some WebAssembly code with that. We need to essentially import that package and use that namespace within that code. So to do that, we just use, and then we can put the wasm-bindgen there. We'll put the prelude in here as well. And then I'm just going to import everything with the star. And then, I've made a little mistake there. So it should be wasm_bindgen. Once I've done that, then you see the squigglies go away, and then we're in a good position. So we've now got our code. And what we can do now is we can build our code, and we'll see what that looks like. And to build something, we're going back to our sort of wasm-pack CLI command. So we'll just type in wasm-pack, and then we would just type in build. Now, there's different targets we can set. We can set web, nodejs, unknown, etc. For the moment, I'm just going to type wasm-pack build. And what you're going to see is it's going to fail on my machine. And this is probably not going to fail on other people's machine, but it fails on my machine because you're going to see this error, no pre-built wasm binaries are available for this platform. Unrecognized target. And the reason that it comes up on my machine is because I'm running an Apple Silicon M1 device. So, but it tells you what you can do, right? To disable wasm-opt. So the problem is with the wasm-opt piece, so the bit that optimizes your WebAssembly modules, you're just basically going to have to switch that off, and then you can make it available later. So if I just come back into and do the optimization later. So if I just come back into vscode for a second, and then what I'm going to do is I'm going to disable that wasm optimizer. So to do that, it's just package.metadata.wasm-pack.profile.release, and you can see whenever I'm creating a release target, then I want wasm-opt to be off. So if I just save that for a second, and then we come back into my terminal, and now what I'm going to do is run that wasm-pack build again, and you can see that it is now built the application. And it's giving me a couple of things, optional fields missing, blah, 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 blah. Not necessary, but recommended. Again, you can fill in the metadata in your cargo.toml file, but that is now built. So if I come back into my Visual Studio Code for a second, and now if I open up this target file, you'll see this wasm32-unknown-unknown. So as you can see, there's a release directory that's been created, and then you'll see underneath that there is a wasm file that has been created for me. So if we go back into my terminal for a second, and we'll just cd into target, and then we'll cd into that wasm32-unknown-unknown, and we'll cd into release for a second. And then you'll see there is that crisp_math.wasm. So if I do an ls-la, and you'll see that it's created something that's about, it's quite a big file actually. So the reason it's quite a big file is basically unoptimized at this stage. So it hasn't sort of shaken the tree and removed things that are not being used. It's got a lot of debug info, etc. So it's much bigger than the thing you would actually wanting to be released. But you know, it's kind of there, and it's cool, and it's generated this WASM file. If I wanted to, I could look at what the generated WebAssembly looks like, and the way I could do that is by converting that WASM file into a WebAssembly text format. So again, if you see my other videos, you'll have seen a tool that we use when we take WebAssembly text format and generate WASM files, and it's called wat to wasm. But there's actually another tool which is called wasm to wat, where you can essentially convert WASM files back into WebAssembly text format. Now, I've got that installed on my machine already. If you want to learn how to install it on your own machine, then in my video, Hello WebAssembly, then it shows you how to install the WebAssembly binary toolkit, Wabbit, onto your own machine. So, but we're not going to do that in this video. It's already installed. So I'm going to call the wasm to wat file. And then what I'm going to do is I'm going to pass in the file that I want to create, which I'm going to call it crispmath .wasm, and I want to output crispmath .wat. So if I return that, that will generate me a as you can see there, a crisp_math.wat file. So that's WebAssembly text format. And then if I open up Visual Studio Code again a second, if we open that up, we will see what the underlying WebAssembly that it's created. So if we look at this, this is really the function that we've created, which is called add two numbers. It accepts in two parameters of i32 of result i32, and then is basically getting those two parameters. And we'll hand code this in a second, and then we'll show it working. But if you do that, it'll add the two together, and that is effectively the code that you've got. But you can probably see there's a whole load of other stuff going on. In fact, 1.6 meg of kind of, I'm going to say this, kind of nonsense that it's generated. It's doing, and to be honest, don't ask me what it's doing, but I think basically what's happening is that the generator is creating a load of stuff for profiling. It's creating a whole load of stuff for more complicated routines. So what you're going to see is that it's actually generated quite a large file there. Now you can optimize this a bit, as I said. So the way you can start to optimize is by going back into your cargo.toml file, and then you can start creating some new settings within there, which will tell you to optimize the release. So if I just type in LTO equals true, what that's basically saying is optimize the release a little bit on build for profile to release, do some optimizations there. And again, if I was to run the build again, so if I just actually come back a little bit, so we'll just cd back here, and then back again, that's fine. And then if we just run the build one more time like we did before, it'd probably be easier for me to type wasm-pack build than doing that. Build that again, take a few seconds. Okay, and then if we go back into our target folder for a second, wasm32, unknown, see the release, and we'll have a look at the file there, and you can see that the wasm file there is a lot smaller. That's been generated, and it's kind of closer to I think that's about 54K. And again, if I wanted to, I could overwrite that WAT file, so I could just generate the WebAssembly text version of that. So if I run my wasm to wat, just run it one more time again, it'll generate a new WAT file. We'll do an ls-la. You can see it's created a new WAT file there. have a look at that. It's probably still fairly big from a WebAssembly text format point of view. We can open that up. You still see it's cut down a little bit, but it's still got a load of stuff in there. And again, if I wanted to, I could optimize even further. And remember that optimizer that we switched off? Then we could basically install that again. So what we would, we could run that optimization manually. So what I would need to do is install a thing called binary en. So if I just type in binary en, that'll install on your machine. I've already got it installed on my machine, so it should be fairly quick. So now that binary en's installed, if I want to run the optimizer manually, I just do a wasm-opt. I do a minus big O Z, and then minus O for output. So I want an output file called Chris_math. Actually, we'll give it a new name. We'll call it opt .wasm. And then I'm going to use Chris_math.wasm as the file. Run that and then do another ls-la. And you can see that it's taken that 54K and it's brought it down to 44K there. So it's given a little bit of optimization there. And again, there are other settings that you can put in there to optimize a little bit further. So if I went back into my cargo.toml file under the profile to release, I could do an opt level. I could put that to S or Z. S is telling you to optimize for size rather than speed. If I save that again, and then if I just did another cargo build, it's going to build that for a second. And then if I go back into the target folder and then back into the release folder, then let's do an ls-la. And you'll see that, again, it's sort of still at 54, so it's not really made any difference there. But again, it's an optimization that you can kind of make. So just play around with the settings need be, but that's basically how you optimize. Okay, cool. So we've created our WebAssembly module in Rust. As you can see, it's fairly simple. And again, if I wanted to, I could create new functions fairly easily. So if I wanted to create a new function and maybe I wanted to call it something like square, and pass in one parameter, then I could just have a function called square, pass in one parameter called n1, and then I could multiply n1 by n1, and then that's going to square numbers together. So it's fairly quick for me to start creating functions and creating new functionality off the back of that. Okay, so now that we've created a code, all we really need to do is just execute it and see it working. So the way to do that is if I come back to my terminal for a second, and what we're going to do now is, if you remember the wasm-pack build command that we had before, instead of not providing a target, now what we're going to do is create a target. And then in this case, we will specify the target is nodejs, and then that's automatically going to generate all the scaffolded code that we need. So if I just type in --target nodejs, and then you see it takes a second there, and then you can see in here it says your wasm package is ready to publish at Rust play Chrismath PKJ. So if I look back in my Visual Studio for a second, you see it's created this package folder, and basically what it's done here is created and scaffolded up everything I need to call my add two numbers function that I created there. So you can see it's got a module exports as two numbers. It's doing all the loading that I need. Everything I need to do to get this working is sort of pre-generated for you. So that's pretty cool. So again, if I were to kind of come back to this now, all I would need to really do if I wanted to get this running in Node.js is create an index.js file for a second. And then we'll execute that. And then all I need to do is create my new library. So to do that, I'm just going to import the chrismath.js file. So I'll just call that math for just now. I'll use require for just now. So if I'll just do require, and then we will put in chris_math.js, and that's me sort of got my file working there. And then all I need to do to call that is just a console.log, and I will do my math.addTwoNumbers, and then I'll pass in the two numbers I want to add together, which is 10 and 20, and then that will console that out. So if I just save that, and then if I come back into my terminal and we go into the PKJ folder that I just created there, And you see the index.js file that we just created and do a node index.js, and you can see it works. So again, if I wanted to, I could put any number in there. I could put 40, hit save, and then run that again, and you see it's added that together. And again, this sort of works. So let me just let's create a new tab here for a second, and then we can go back and mess around with things again. So if I just come back here, we'll build that again like we did before. But what I'm going to do now is change my code. So rather than just having to add two numbers, let's have the square function back again. So we'll put square. That will just be one parameter. We'll do n1 times n1, which is going to be square. And then I will rerun my wasm-pack build. So wasm-pack build, I'll set that to nodejs, minus target nodejs. That will build a new version of that package. So if we come back into package for a second, you can see I've still got my index file that we had before. But if I were to open up the Chris math, you can see it's created the square function now. And again, if I wanted to change that, so let's, rather than adding two numbers together, in fact, we could, the add two numbers will still work. So we'll do 10 and 20 and 17, that should equal 80. So if I just run my node index.js, you'll see that should still work there, which it does. But now if I come back into here and then change that so it's doing a square, and this time I want to square 10, and then run that again, it should come back with 100, which it does. So this is where that target side of things works really well. It's really easy to create code from Rust and then move it around. And again, you can mess around with the optimization, you can add new functions, and again, it's much quicker than hand coding WebAssembly. So again, it's just something to kind of be aware of for a second. It does all that scaffolding for you, so it's pretty cool stuff. The sizes, because it's got all this optimization stuff, it's probably a little bit bigger than you would do for these simple functions if you were to hand code it. But I think it's kind of pretty cool stuff anyway. So finally, as I said, this created for Node.js bindings. If I wanted to create bindings for web, then I would do that as a web side of things, and then it would generate me my web coding. But I'm not going to do that just now, because you can do that in your own time. Just change the target to Node.js, and then it'll create a whole set of files for you, and you're kind of good to go. So that is how you get to use things in Rust. It's fairly cool. It's very, very quick. The only thing I would say is that for simple functions, they're quite big. So, if you think of that WASM file that I created there, it's still sort of 45K. I said I was going to sort of prove a point there, but if I genuinely wanted to create my own math function there, so if I just do a cd ... here, and then I created a new folder called Chris Math 2. Yep. We'll just do a code dot. If I wanted to create my own WebAssembly handcoded file, then I could do it as a WAT format there. And probably as you would have seen before, for me to create something like the square function. So let's create something called chrismath.wat. All I would be doing is a kind of module, and then I could create func. We'll call that square. Let's make this a little bit smaller there. I would set my param to be an I32. I would set my result to be I32. Let's make that there for a second, and then to make that work, I would just do a local.get0. I'd do a local.get0, and then I would do an I32 mul. And then if I wanted to export that out, it would just be an export square. And I want that to be a function called square. So we'll just call that, sorry, I need func, and then put square in there. And that would be my wasm file there. And again, if I wanted to convert that from WebAssembly text format to a wasm file, so yeah, this is where this is where I had my wabbit. So this time, rather than doing wasm to wat, I'm going to do wat to wasm. And then what I'm going to do is pass in chris_math.wat, and I want to output that to chris_math.wasm. And then if I return that there, oh no, directly, I've given it the wrong name. That's why I did an underscore. So let's just move that to a dash. And then do an ls-. So it's created my wasm file, and you can see my wasm file is 43 bytes, right? So there's a substantial difference between the code that I've generated for the wasm file. It's tiny in comparison to what Rust has generated. And the reason is Rust is bringing on all this other stuff that it needs to deal with, kind of memory allocations and standardized libraries that it needs to use for other programs. So, mine is 43 bytes, that's 44K. There's a substantial difference. But of course, as you get to larger programs and routines and libraries, then it's going to be unnoticeable. But it's just something to be aware of. There's a little bit of bloat that's coming with the Rust libraries, so it's not really optimized for size, and you can kind of see that. So that was the code I wrote, but if I come back into the source file here and we look at the wat that we created earlier, so if I come in here, remember we created chris.math.wat. This is the same code, this is add two numbers, but this is essentially the same code as I wrote earlier. Okay, so it's very similar to what I wrote, but as you saw, it's got all this other kind of optimizations and junk and memory allocations and stuff that Rust WebAssembly might need when you're creating Rust programs in general. So it makes sizes a bit bigger, so it's just something to be aware of. But the fundamental add two numbers code is kind of the same there. So anyway, I hope you get the sort of the differences there. As you can see, Rust is a very cool tool. It's a really great way of creating WebAssembly. And then as you start creating larger libraries and stuff, then some of that bloat stuff isn't really going to matter. The only thing I would say there, to create stuff in Rust, as you can see, square functions, add two numbers together or whatever, it's fairly quick. Whereas as soon as you start getting into more complicated stuff, that's where Rust is going to come in its own, and where handcoding WebAssembly doesn't really work out. So you need to sort of put your own trade-offs and balances there, but hopefully you can kind of see Rust is really cool. It's a great way of generating WebAssembly, and as you start to get into more complicated libraries, to be honest, handcoding WebAssembly is probably just a jump too far. Anyway, I hope this has been useful. I hope you understand how to put things together, and I will no doubt catch you on the next video.